So today we are learning all about molar mass. So what is molar mass? Molar mass is the mass of exactly 1 mole of a given substance. So if I ask you for the molar mass of carbon dioxide gas, then that would be the mass of exactly 1 mole of carbon dioxide gas. The symbol for molar mass, you can remember it because it looks a little bit like a molar but upside down. Molar is kind of pointy like that. It looks like an upside down M, and that's what the symbol for molar mass is. It's a capital M. Notice it's not a lowercase m. The symbol lowercase m means mass. Molar mass is capital M. The units of molar mass are grams per mole, and that unit actually makes a lot of sense because it comes from the definition. If the definition of molar mass is the mass of exactly 1 mole of a substance, then it would make sense that its units are a mass, grams, per mole. So grams per mole is your unit of molar mass. So symbol, capital M, unit, grams per mole. For an element, it's pretty straightforward to grab the molar mass. You can actually read it right off your periodic table. So we've talked about before the average atomic mass on the periodic table. That's the mass of your average atomic mass for all the different isotopes of that element. We've talked about it in terms of atomic mass units, and that's true, right? The atomic mass of boron is 10.81 U atomic mass units. That average atomic mass actually is also the molar mass of boron. So that number you can read right off your periodic table, the 10.81 right underneath the name of boron or whatever the element is the molar mass of boron. So if I ask you, hey, what's the molar mass of the element boron? It's just 10.81 grams per mole. And the unit when we talk about it as a molar mass is grams per mole, but it's the same number, just a different unit, different way of talking about it. It gets a little bit trickier when you're talking about a compound. So when you have a compound that's a bunch of different elements together, how are you going to get the molar mass of that? Well, what we do is we write out the formula for the compound, and then we figure out how many of each element do I have in this compound, and I multiply the molar masses by those subscripts and add them all up. So that'll make more sense with an example. I'll show you how this works. Let's say you have to find the molar mass of water. Well, your first move is just going to be to write down the molar masses of each component of water. Right? Water is made of H2O, right? It's 2 hydrogens. I'll just write this down. So H2O, right? So there's going to be 2 H's and 1 oxygen. So I'm going to need to know the molar mass of each part of that, right? The molar mass of the hydrogen is 1.01 grams per mole, and I can read that right off my periodic table. The molar mass of the oxygen part of water, read that right off your periodic table too. It's 16.00 grams per mole. How do you put that together to get a molar mass of the entire compound? Well, you take that formula and you're going to add up all the little elements in that formula. So there are 2 H's, so I'm going to do 2 times the molar mass of hydrogen, and then add that to 1 times the molar mass of oxygen, because there's only 1 oxygen. So it looks like this. We've got 2 H's, so 2 times the molar mass of hydrogen, plus 1 oxygen, just plus the molar mass of 1 oxygen, which is 16. Add that all up, and that gives you 18.02 grams per mole. Just in terms of significant figures, notice that we're doing adding here, right? So we're going to use the adding rule for sig figs, which is that you go to the smallest number of decimal places. All of the molar masses on your periodic table are to 2 decimal places. So that means that your molar masses are going to be reported to 2 decimal places as well. So that's how I know I need to round that off right here at 18.02 grams per mole. Let's try a harder example. What if you had aluminum sulfate? So I'm going to grab my periodic table and I'll see the molar masses of each of those. There's aluminum, has a molar mass of 26.98 grams per mole, sulfur, 32.07 grams per mole, and oxygen, 16.00 grams per mole. First move I'm going to need is my chemical formula for aluminum sulfate. So remember, aluminum has a charge of 3. Sulfate is that polyatomic ion, which is, so aluminum is Al with a positive 3 charge. Sulfate is a polyatomic ion. Its SO4 is its formula, and it has a charge of -2. So put that together to make a chemical formula. You're going to need 2 aluminums and 3 sulfates. It'll look like this. So I've got 2 aluminums and 3 of my sulfate ions. Okay, how am I going to add this all up? So that means in terms of molar masses, I have 2 aluminums, right? There's 2 aluminums in my chemical formula. For sulfurs, so here's the sulfur. Sulfur is inside that polyatomic ion of sulfate, and there are 3 of those polyatomic ions. So I have 1 sulfur per sulfate ion and 3 sulfate ions. That means I've got 3 sulfurs altogether. Now the trickiest one is oxygen. There are 4 oxygen atoms inside a single sulfate, and then there's 3 sulfate ions here inside my chemical formula. So there are 4 times 3, or 12 oxygen atoms in this guy here. So 2 aluminums, 3 sulfates, and 12 oxygens. To get your molar mass, what you're going to do is multiply the molar mass of each element by how many times it shows up in your chemical formula. So aluminum, there's aluminum, shows up twice, so we multiply by 2. Sulfur shows up 3 times. There's 3 sulfurs in there, SO4, 3, right? And oxygen, there are 12 oxygens, 4 times 3 oxygens in my chemical formula, so I'm going to multiply that molar mass of oxygen, 16, by 12. Then just add them all up. So notice this is adding, not multiplying. There, you just add them all up. Our symbol here is big M for molar mass. One way I like to do it so that I can just write it all in one statement is I'll say big M and then I'll subscript, write down that chemical formula as a subscript to the big M. That way I don't have to write it separately up here. I can just write it all in one line. So I'll write big M for molar mass and then aluminum sulfate with its chemical formula so I can see how many of each thing I've got. And just put it all in one line. Just speeds up your process. The number of significant figures that I can keep here is going to be to 2 decimal places, and that's because I'm using my adding rule, right? So there's 2 decimal places, 2 decimal places, 2 decimal places. So I add those all up, and I get 342.17. The unit is grams per mole. It's my unit of molar mass, grams per mole. And that is how you calculate molar mass for a compound.